Good evening, sir.
Yes, good evening. Yes, let me start. Briefly introduce yourself.
So my name is Avantika. I belong to Hisar and I have completed my matriculation and 12th from Holy Angel School, Hisar. I did my dual degree course in chemistry honors from Guru Jambheshwar University of Science and Technology, Hisar, which is in Haryana.
Yes, good. So let's move on. Today topic is chemical kinetics. Yes. What is chemical kinetics?
So chemical kinetics is the branch of chemistry which deal with the rate of chemical reactions and the factors affecting rate of chemical reactions.
What the main application of chemical kinetics?
It determines the time in which the reaction can be completed. Because from thermodynamics, we only know the feasibility of a reaction, and from chemical equilibrium, we only know that to which extent the reaction will proceed. So the major application of chemical kinetics is that because from chemical kinetic time, the reaction can complete.
What's the difference between rate law, rate equation, rate of reaction? Explain one by one on board. Yes. Carry on.
Sir, rate law can be defined as the dependency of a concentration of reacting species on the rate of a reaction. We can write as A plus B, let if it is making product B. Then according to rate law, here the powers can be equal or not equal to the stoichiometric coefficient of the reactants. And in law of mass is used for elementary reaction. Case of law of mass action for elementary reaction, we will express rate in with the help of stoichiometric coefficient of the given reaction. Here, because stoichiometric coefficient is 1 for A and 1 for B, then the rate will be A exponent power 1 and B exponent power 1. But in case of rate law, the stoichiometric coefficient can be equal or not equal to the power, because here the order will be determined by experiment. And if we have to find the rate law equation for a reaction, then the average rate of reaction can be expressed as this is the rate of a reaction for a complete reaction. Here it is depending on the stoichiometric coefficients present, but if we have to find only the rate of appearance or disappearance of products and reactants, then they will not depend on the stoichiometric coefficients in the given reaction, or we can say they will not depend on the balancing of the reaction.
Yes, good. What the graphical representation of a rate of reaction?
The rate of reaction can be expressed in many ways. Like for a rate of reaction, there is change in some properties in chemical reaction upon change in time. So rate can be expressed in terms of number of moles. Change in number of moles upon change in time, and it can also, if we put the formula of number of moles, that is weight upon molecular weight, then we can also express rate in terms of weight. We can also express rate as a change in concentration, that is mole per liter upon change in time, and also in terms of pressure. But if we but the rate law equation, the generalized rate law equation is only used only when the rate is expressed in terms of mole. If we have to express a rate in terms of pressure, then we use the ideal gas equation, that is PV is equal to nRT. So here from this equation we will get P is equal to N by V RT, where N by V is concentration, so P is equal to CRT. So when we express this in terms of rate, we will multiply it by V upon 1 by RT, so that this expression can be cancelled, and we get delta P, that is change in pressure upon change in time, into V upon RT.
Next, move on. Order of reaction and molecularity. What is the difference?
Sir, difference between?
Order of reaction and molecularity.
Sir, order of reaction is determined experimentally, and order of reaction is the sum of powers, whereas the molecularity is the sum of the stoichiometric coefficient or the number of molecules that are colliding. The order of reaction can be zero, negative, positive, or fractional, but the molecularity of a reaction cannot be zero or negative. It can only be whole number.
Yes. What is zero order of reaction? What is the half-life of zero order reaction?
Overall reaction, but the molecularity of reaction is you can be determined only for the elementary step reaction. Molecularity can't be used for the complex reaction.
What is the half-life of zero order reaction?
A naught by 2 cases.
What is the graph of zero order of reaction? Rate versus time and concentration versus time.
Sir, zero order reaction is independent of independent of the concentration, so it will have linear graph. We can draw it as for zero order reaction. So because it doesn't depend, so the rate versus time graph for zero order reaction is constant.
Yes.
And concentration and time graph, if we have to draw for zero order reaction, then because for zero order reaction the expression is like x is equal to kt, where x is a naught minus at. Then if we have to draw graph between the at, that is the remaining concentration of a after time t, then it is linearly decreasing graph, and we here we get the slope of k. And if if this graph line touches the x-axis, then here the 80 value of 80 becomes 0. So when we put the value of 80 0 in the expression k is equal to a naught minus 80 upon t, so then we get k is equal to a naught by t, and t is equal to a naught by k. this is the time of completion. So the zero order reaction completes in A naught by K time interval.
Yes, graphical representation of first order of reaction.
Sir, in case of first order reaction, the like if it is linearly depending on concentration, the rate is linearly depending on concentration, that is rate is equal to concentration raised to the power 1. So when we draw the graph of first order, rate between rate and concentration, then we get this graph that is linearly increasing graph, and with the expression is rate is equal to Ka, that is first order. So from y is equal to mx, the slope here comes K, and if we have to draw the graph between rate and time, so from the exponential expression of first order reaction, that is rate is equal to K A naught e raised to the power minus kt. So from this equation, the graph between rate and time comes as exponentially decreasing graph, and this exponentially decreasing graph is not will not meet this x-axis line. So the this reaction will not complete. So from here we say that the zero order reaction completes in, sorry, first order reaction completes in infinite time.
Yes. What is the limitation of first order of reaction? Zero order of reaction and first order?
Sir, in case of zero order reaction, we the it is not depending on concentration of reacting species, so we can't find the we can't find the decom decomposed
Yes. Second order of reaction.
Sir, second order express expression that I could say.
Yes.
Sir, second order reaction is the reaction in which the rate the rate is equal to concentration raised to power 2. So if we double the concentration of any reactant, then the rate will be increased to 4 times. And the expression for second order reaction is K is equal to 1 upon T, 1 upon A naught minus 1 upon AT. And half-life for second order reaction is 1 upon Ka naught.
Yes, explain on board. Graphical representation of second order of reaction in chemical kinetics.
So for second order reaction,
Yes, rate versus concentration, and concentration versus time, concentration versus rate constant.
rate versus concentration. So for second order reaction, the expression is because the expression is K is equal to 1 upon T, 1 upon AT minus 1 upon A naught. So from here we got to know that here K is equal from here the rate versus here the rate is increasing as we increase the concentration. So here the graph between rate and concentration is a linearly increasing graph, like the first order reaction. And the graph between T half and concentration, because it is inversely proportional, then we because the we here it is inversely proportional, then we get the decreasing graph.
Yes. Any limitation of second order of reaction?
So limitation of second order reaction.
Yes.
Sir, from second order reaction, the if we have in mostly in case of second order reaction, we have two reactant molecules, and from that we get the product molecule. But in some cases, if the reactant molecule is one reactant molecule is taken in much excess, then the rate doesn't depend on the concentration of that reacting species, and rate only depends on the one reactant concentration. So in spite of being two two reactant, the rate only depends on one reactant concentration, so it becomes a pseudo first order reaction. For example, in case of hydrolysis of ethyl acetate, when we take concentration of water in excess, then the rate doesn't depend on and rate only depends on the concentration of acid.
Yes. Next, third order of reaction. What is third order of reaction?
The third order of reaction, if we increase the concentration of reactant 3 times, then the rate will become 9 times. And the expression for third order or nth order of a reaction can be expressed by the general expression like if we have a reaction A is giving product B, then let it, at time t is equal to 0, we have initial concentration A naught, and here because now nothing has reacted, so concentration of B is 0, and at time t this concentration of A becomes 80 and B becomes let x. Then when we express the rate minus dA by is equal to k n, where n can be uh, any order of the reaction except first order of the reaction. So when we integrate this, so from here we get the expression k is equal to 1 upon t 1 into 1 upon n minus 1 1 upon 80 n minus 1 minus 1 upon a naught n minus 1. And when we put here the n is equal to third, then we get the expression of third order reaction. So from here we get the expression of third order reaction as K is equal to 1 upon 2T 1 upon AT square minus 1 upon A naught square. So the expression of third order reaction is 1 upon 2T into 1 upon AT square minus 1 upon A naught square. Similarly, we can also find the half-life of third order reaction if we put the value of AT as A naught by 2. Then we get the T half of third order reaction as 1 upon K 1 upon K into 1 upon 2 in like we have a general expression for half of nth order of reaction. The general expression for finding T half of nth order of reaction is T half is equal to 1 upon K 1 upon n minus 1 2 raised to power n minus 1 minus 1 minus 1 upon A naught n minus 1. So when we here put the value of n is equal to 3, then we'll get the expression. So the expression for T half for third order reaction is 3 by 2K into 1 upon A naught square.
Yes. How to graphical representation versus rate versus time, concentration versus time in third order application.
Sir, because for third order reaction, we have derived the expression as so when we have to draw the graph between rate and concentration, in case of third order reaction, because here the rate we get increasing graph
Yes.
it will
Yes, rate and
I'm not
concentration.
recalling, sir.
Your middle point. Rate concentration. Graph.
Sir, it will be increasing graph, but don't know linearly. It will linearly increase or exponential.
Linear. Any limitation of third order of reaction? What the half-life of third order of reaction? For second and third.
Sir, half-life for a second order reaction is 1 upon Ka naught, and half-life for third order reaction we can derive by the general expression. Because the general expression for finding T half is from the general expression we will sir, the half-life for third order reaction will be 3 by 2K into 1 upon A naught square.
Yes. Yes, what is the example of reaction in zero order, first order, second order, third order?
Sir, zero order reaction, the example we can take give the example of decomposition of we can give the example of decomposition of ammonia, and also the the reaction in which light is used. For example, if we have H2 gas, the Cl2 gas in presence of light, we get HCl. So here the reaction is not depending on the concentration of H2 and Cl2. So here the rate becomes equal to K, that is constant, and for first order reaction,
SN1 first order, second
any
order.
radio.
Yes. SN1 first order, SN2 second order reactions. Third order 2NO plus O2, 2NO2.
Yes, sir. And every radioactive process is
Yes.
first order
First
reaction.
order reaction. Yes, right. Yes, good. Today, good work from your side.